Good day, mathletes. Our lesson for today is about factoring polynomials. Factoring a polynomial means expressing it as a product of prime polynomials. There are different techniques in finding the factors of polynomials. First, find the common monomial factor. Second, factoring polynomials that are different of two squares. Third, factoring polynomials that are perfect square trinomial. And fourth, factoring polynomials using synthetic division. Let us take 3x cubed minus 6x squared minus 105x. So using common monomial factor, we're going to determine the greatest common factor by using the coefficients. So we have 3, negative 6, and negative 105. So, since these are divisible by negative 3, and all of these terms has common variable part, so therefore, the greatest common factor is 3x. Divide all the terms by the greatest common factor. So, 3x cubed divided by 3x, we have x squared. Negative 6x squared divided by 3x, we have negative 2x. Negative 105x divided by 3x, we have negative 35. Therefore, we have 3x times the quantity of x squared minus 2x minus 35. That is using common monomial factor. But since if we are required to factor it completely, x squared minus 2x minus 35 is still factorable. That is using our knowledge in trial and error method or using the perfect square trinomial. So the complete factor is 3x times the quantity of x plus 7 and x minus 5. So this is the complete factors of the given polynomial. Next example is 16x to the fourth minus 1. So to factor it, we're going to use our knowledge in difference of two squares. So the pattern is a squared minus b squared equals the quantity of a plus b times the quantity of a minus b. So notice that for the first term, we're going to get the root of the first term the same with the second term. And then the operation between them is addition and subtraction or positive and negative. So in this example, a squared here is 16x to the fourth and b squared is positive 1. Now, since this is an example of difference of two squares, so first we're going to draw two parentheses. The operation between them is addition and subtraction. And then, get the square root of 16x to the fourth. And that is 4x squared. And then, get the square root of 1. That is positive 1. So, hence, the factors of the given polynomial, 16x to the fourth minus 1, is 4x squared plus 1 times 4x squared minus 1. But take note that this is still difference of two squares. So this is reducible into this form. So a plus b times a minus b. So just bring down 4x squared plus 1. And then 4x squared, the square root of this is 2x. And then the square root of 1 is 1. So hence, the square root of 4x squared minus 1 is 2x plus 1 times 2x minus 1. So this is the complete factors of 16x to the fourth minus 1. Next, another example is x squared plus 10x plus 25. So we're going to factor it using perfect square trinomial. So, if the given is a squared plus 2ab plus b squared, it is factorable into the form a plus b squared. Another is a squared minus 2ab plus b squared is equal to the quantity of a minus b squared. So in this example, this is an example of perfect square trinomial. So first, we're going to draw one parenthesis with an exponent of 2 or in the second power. Then in this pattern, since the sign of the middle term is positive, so we're going to use this pattern. The operation involved is the sign between the two terms is addition or positive. So we're going to use this pattern. Then get the square root of the first term, so that will be a. So in this case, we have the first term, which is x squared. So the square root of x squared is x. And then for the b squared, which is the last term, the square root of b squared is b. So for our example, the last term is 25. So the square root of 25 is 5. Okay? So therefore, the factor of x squared plus 10x plus 25 is x plus 5 squared and can be expanded as x plus 5 times x plus 5. So another example, number 4, x squared minus 14x plus 49. In this case, the sign of the middle term is negative. So we're going to follow the second pattern. So first, we're going to draw one parenthesis wherein the operation between the two terms is negative and it is raised to the second power. Then get the square root of the first term, x squared. So the square root of x squared is x. And then the square root of 49 is 7. Hence, the factor of the given perfect square trinomial is the quantity of x minus 7 squared. And it can be expanded as x minus 7 times x minus 7. Okay, number 5. The given is 4x squared plus 12x plus 9. So again, we're going to follow the first pattern since the sign of the middle term is positive. Take note that this is an example of perfect square trinomial because the first term and the last term are both perfect square. So first, draw one parenthesis wherein you just simply copy the sign of the middle term, which is positive. Then the degree is the exponent or the power is 2. Then get the square root of 4x squared, that is positive 2x. And the square root of the last term, 9, that is 3. Hence, the factor of the given polynomial is the quantity of 2x plus 3 squared, or it can be expanded as the quantity of 2x plus 3 times the quantity of 2x plus 3. Number 6. So the given is 9x squared minus 24x plus 16. Again, this is an example of perfect square trinomial because the first and the last term are both perfect square. So draw one parenthesis, copy the sign of the middle term, which is negative, and then the power is 2. Then get the square root of 9x squared, that is 3x. And then the square root of the last term, 16, that is positive 4. Therefore, the factor of the given polynomial is the quantity of 3x minus 4 squared, or can be expanded as 3x minus 4 times 3x minus 4. Next, another method in factoring polynomials is using synthetic division. So, for number 7, we have 3x cubed minus 6x squared minus 105x. So, first, we're going to get the common monomial factor, that is 3x. So, factor out 3x from the given expression, we will have x squared minus 2x minus 35. So, how? Just simply divide the first term, 3x cubed by 3x. So, cancel yung 3. Then, x cubed divided by x, that will be x squared. Then for the second term, negative 6x squared divided by 3x. So, negative 6 divided by 3 is negative 2. X squared divided by x is x. Then for the last term, negative 105x divided by 3x. So, negative divided by positive, negative. 105 divided by 3 is 35. So, cancel yung x. Then, using synthetic division, just simply copy the coefficients 1, negative 2, and negative 35. And then you're going to try a multiplier from the last term, or from 35. The number that are divisible by 35 are 1, 5, 7, and 35. Now, let us take negative 5. Let us consider negative 5. So, using synthetic division, we just draw a long line and then bring down the first term. And to be put on the bottom row. Then, all the numbers on the bottom row will be multiplied in our multiplier, negative 5. So, 1 times negative 5, that is negative 5. Then add the first and the second row. So, negative 2 plus negative 5, that is negative 7. Then again, multiply negative 7 times negative 5, that is positive 35. Then add negative 35 plus 35, that is 0. So, negative 5 is the root since the remainder is 0. Hence, one of the factor is x plus 5. Then, since there are two remaining numbers on the bottom row, we can express this as a linear factor. Just put a variable on the first term, so we have x minus 7. So, x minus 7 is another factor. Hence, the complete factor of the given polynomial 3x cubed minus 6x squared minus 105x is equivalent to the quantity of x minus 7 times the quantity of x plus 5 times 3x. Okay? So, again, we have to factor out the common monomial factor. And then, afterwards, we're going to use synthetic division. You may use also the perfect square trinomial. Next, the given is 2x cubed plus 3x squared minus 11x minus 6. So, the degree is 3. So, when we say degree, it is the highest exponent. So, therefore, we all know that for every polynomial of degree n has at most n real roots, meaning there is at most 3 real roots in the given polynomial, or at most 3 factors. So, using synthetic division, as you're going to bring down all the coefficients. So, we have 2, 3, negative 11, and negative 6. But take note that we have to consider that the given polynomial should be in the standard form, meaning it should be arranged in decreasing powers of x. And then, after arranging the given polynomial in standard form, you have to look for the missing term. So, since the given has no missing term, you just simply bring down all the coefficients. So, we have 2, 3, negative 11, and negative 6. And afterwards, you're going to identify multiplier. The multiplier will be obtained using the last term, which is 6. Now, the number that are divisible by 6 are 1, 2, 3, and 6. You're going to try all these numbers, either positive or negative. So, let us take positive 2 using synthetic division. So, first, you're going to draw long line, then bring down the first term, 2, to be put on the bottom row, and then all the number on the bottom row will be multiplied to the multiplier. So we have 2 times 2, that is positive 4. Then again, the first and the second row will be added. So we have 3 plus 4, that is 7. Then 7 times 2, we have 14. Again, the first and the second row will be added. So we have negative 11 plus 14, that is positive 3. Positive 3 times 2, positive 6. Negative 6 plus 6, 0. The last term is the remainder. If the remainder is 0, we can say that the multiplier 2 is one of the root of the given polynomial. And we can say that x minus 2 is a factor. Then, continue using synthetic division using the depressed equation or the depressed coefficients. So we have still remaining 3 numbers on the bottom row. So we have 2, 7, 3. Now, since the last term is 3, let us try 3. You may use either positive or negative. So let us try negative 3. Then again, draw a long line. Then bring down positive 2, then multiply the bottom row to our multiplier. So 2 times negative 3, that is negative 6. Then add 7 plus negative 6, that is positive 1. 1 times negative 3, we have negative 3. Then 3 plus negative 3, that is 0. Again, since the last number is 0, we can say that negative 3 is also the root of the given polynomial, and at the same time, x plus 3 is one of the factor. Then, since we still have the 2 remaining numbers on the bottom row, we can reduce this into linear factor. So, just simply put letter x beside the first term, so we have 2x plus 1. So 2x plus 1 is another factor. So since there are at most 3 factors, we can say that the complete factors of the given polynomial is the quantity of 2x plus 1 times the quantity of x minus 2 times the quantity of x plus 3. So we can also apply the rational root theorem. So given a polynomial function defined by p of x equals a sub n x to the n plus a sub n minus 1 times x raised to n minus 1 and so on and so forth until a sub 1x plus a sub 0 with integer coefficients, and where n is a non-negative integer, the possible rational roots of p of x are the form p over q, where p is a factor of a sub 0 and q is a factor of a sub n. Note that a sub 0 is the constant term, a sub n is the leading coefficient, n is the degree of the polynomial, p of q in lowest term are the possible roots. For example, we have 2x to the fourth plus 7x cubed minus 6x squared minus 7x plus 4. So, since the given polynomial is already arranged in standard form, we can easily identify the degree of the polynomial. And the degree is 4. So, since this is the leading term, we can say that the leading coefficient is 2, which is represented by a notation a sub n. Okay? So, the factors of the leading coefficient are 1 and 2. Then we have also considered the constant term wherein it is represented by a sub 0. The factors of the constant term 4 are 1, 2, 3, and 4. Meaning, these are the set of numbers that are divisible by 4. Then afterwards, we're going to identify all the possible rational roots represented by P over Q. So take note that P over Q should be in the lowest term. So first, we're going to represent this set of factors divided by the factors of A sub n. So 1 divided by 1, that is 1. 1 divided by 2, we have 1 half. Then next, 2. 2 divided by 1, we have 2. 2 divided by 2, we have 1. Next, 3. 3 divided by 1, we have 3. 3 divided by 2, we have 3 halves. Next, 4. 4 divided by 1, we have 4. 4 divided by 2, we have 2. So therefore, these are this is the set of the possible rational roots in the lowest term. So we have 1, 2, 3, 4, 1 half, and 3 over 2. So another way is just simply copy all the factors, the set of factors of the constant term, which is 1, 2, 3, 4. And then to obtain the fractional form, just simply divide this given set of factors by the factors of A sub n. So that we will come up with 1 half and 3 halves. Okay, take note that all of this term has a positive and negative sign. The degree of the given polynomial is 4, meaning the highest exponent is 4. Hence, there are at most 4 factors. Take note that every polynomial of degree n has at most n real roots. Okay? So, again, consider that the given is, you have to consider that the given polynomial should be arranged in the standard form. Okay, since the given is in the standard form, just simply bring down all the coefficients of the given polynomial. So we have 2, 7, negative 6, negative 7, and then positive 4. Now, we're going to try out all of these possible rational roots. So let us take positive 1. And using by drawing a long line, you're going to bring down the first term 2, then multiply it to our multiplier 1. So 2 times 1, we have 2. 7 plus 2, we have 9. 9 times 1 is 9. Then negative 6 plus 9, we have 3. 3 times 1, 3. Negative 7 plus 3 is negative 4. Negative 4 times 1, we have negative 4. Then add 4 plus negative 4 is 0. Since the last term is 0, or the remainder is 0, we can say that 1 is one of the root. Then, x minus 1 is one of the factor. Then, continue getting the root and the factor of the given polynomial using the 4 remaining numbers on the bottom row. So let us take negative 1. Take note that this number is coming from the set of possible rational roots. So bring down 2, then multiply 2 and negative 1, we have negative 2. 9 plus negative 2, we have 7. 7 times negative 1, we have negative 7. 3 plus negative 7, we have negative 4. Negative 4 times negative 1, positive 4. Negative 4 plus 4, 0. Again, since the remainder is 0, we can say that negative 1 is one of the root and x plus 1 is one of the factor. Continue using synthetic division using the remaining numbers on the bottom row. So since the last term is 4, we can try either 1, positive or negative 1, positive or negative 2, or positive or negative 4. So let us try negative 4. Then bring down positive 2. 2 times negative 4, we have negative 8. 7 plus negative 8, that is negative 1. Negative 1 times negative 4, we have positive 4. Negative 4 plus 4, 0. Again, the last number or the remainder is 0. Hence, since the remainder is 0, we can say that negative 4 is one of the root and x plus 4 is the factor. So take note that there are two numbers left on the bottom row. So we can reduce it or we can write this in the linear factor by putting variable x beside the first term. So we have 2x minus 1. As you can see, the sign of the given term is not changed. So just simply copy the sign negative 1. Okay? So we can say that 2x minus 1 is one of the factor of the given polynomial. So therefore, the complete factors of 2x to the fourth plus 7x cubed minus 6x squared minus 7x plus 4 is 2x minus 1, x minus 1, x plus 1, and x plus 4. Okay? So, as you can see, there are 4 factors because the highest exponent or the degree of the given polynomial is 4. Thank you, Mathletes, for watching. If you have any questions or clarifications, do not hesitate and feel free to write your questions in the comment box section. Kindly tap the like and subscribe so that you will be notified in my next video. Happy learning!